Hello, welcome back for chapter 2. So chapter 2, we're going to start working with descriptive statistics. Remember, in chapter 1, we learned about two types of statistics, inferential and descriptive. And so we're going to move into descriptive, and we're going to start with 2.1. And we're going to start with some stem and leaf graphs. So a stem and leaf graph, what it does is it kind of organizes the data by whatever you choose as the stem or the starting points, kind of like a tree. So we're going to have, I'm choosing, because my smallest value is 33, I'm going to start with my tens as my stem. So I'm going to mark that here, my tens. And then my ones are going to be my leaf. And so I'm going to mark just my stems. So my possible stems, looking at my data, are 3 all the way through 10, because 100 is 10, 10 tens. And even if I don't have any of, let's say I didn't have any 50 in the 50s on the first exam for pre-calculus scores, I still have to put that stem so that I can see that there were no observations that met that criteria. So you can see that there was 133. So that stem there, I'm just going to put a 3 for the ones. There are 3 that are in the 40s. And I'm noting those by the 2, the 9, and the 9. So I can count the leaves and notice that there were 3 observations in the 40s. There were 1, 2, 3, 4, 5, 6, 7 observations in the 60s. And you can see that up here. Okay, we're going to get a chance to make our own. Reading them and pulling out the important parts is a critical feature as well, a skill that we want to really get good at. So the stem plot shows that most scores fell in the 60s, 70s, 80s, and 90s. So this kind of chunk here, kind of really in 2 big groups, the 60s and the 90s. 8 out of the 31 scores are for approximately 26%. We're in the 90s or 100, a fairly high number of A's. So let's try one on our own. For the Park City basketball team, scores for the last 30 games were as follows. So it's good to know that there were n equals 30. Smallest to largest, construct a stem and leaf plot. So again, I can see that my smallest number is in the 30s. I'm going to do these as my 10s and these as my 1s. And so I'm going to start with 3, and my largest goes up to 60. So I have 3, 4, 5, and 6. And so I've got 32, 32, 33, 34, and 38. I'm going to cross those off as I go. And I'm going to list all my 40s. So I've got 40, 42, 42, 43, 44, 46, 47, 47, 48, 48, 48, 49. And then in the 50s, I'm going to list those. I've got 50, 50, 1, 52, 52, 52, 53, 54, 56, 57, 57. And then in the 60s, I've got 60 and 61. And I can count to make sure I have 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. What is an observation you can take from the stem and leaf plot? The majority of the scores were in the 40s and 50s. You could also break apart if you wanted to do the 40s to 45 and then the 46 and above, you could do it that way. if you wanted to kind of break them apart a little bit. So the stem plot is a quick way to graph data and gives an exact picture of the data. You want to look for an overall pattern and any outliers. An outlier is an observation of data that does not fit the rest of the data. It is sometimes called an extreme value. When you graph an outlier, it will appear not to fit the pattern of the graph. Some outliers are due to mistakes. For example, writing down 50 instead of 500. While others may indicate that something unusual is happening. It takes some background information to explain outliers, so we will cover them in more detail later. We're going to talk about outliers all semester. So let's make another stem and leaf. This is the data for the distance in miles from the homes of off-campus statistics students to the college. Create a stem and leaf plot using the data and identify any outliers. So it looks like we have tens again. Oh, actually, these are all just going to be ones. Ones are going to be our stem. And then the tenths are going to be our leaf. And because 0.5 is our smallest, our first stem is going to be a 0 in the ones, and we're going to have a 5 and a 7 to represent the 0.5 and 0.7. And then our largest is 8. So we need to go all the way up through 8. So 0, 1, 2, 3, 4, 5, 6, 7, and 8. I didn't make quite enough here. Okay. And then in the ones, we've got 0.1, 0.2, 0.2, 0.3, 0.3, 0.5, 0.5, 0.7, 0.7, 0.8, and 0.9. And then our twos, we've got 0.0, 0.2, 0.5, 0.6, 0.8, 0.8, 0.8. And then our threes, we have 0.5, 0.8. And our fours, we have 0.4, 0.8, 0.9. And our fives, we have 0.2, 0.5, 0.7, 0.8. And there aren't any 6 or 7s, but remember, we still have to have a spot for them to recognize that there's this chunk of data over here, and then we have this last value right here. And so that's important because that's where we're going to note that this 8.0 is our outlier down here. And had we left out the 6 and 7 and just put the 8 next to the 5, we may not have noticed that that was an outlier. We can also do a side-by-side stem and leaf plot. It allows us to compare 2 data sets in 2 columns. In a side-by-side stem and leaf plot, 2 sets of leaves share the same stem. So let's look at this example here. So we're looking at data on the number of wins and losses for the Detroit Pistons in the last 20 seasons. Create a side-by-side stem and leaf plot of these wins and losses. So I started with the year 2002. And it goes down to 2011, and then we go back up to here with 2012 through 2021. So my stems, I have to start with my lowest number of wins or losses. I've got some in the teens. So I know that I have to have a stem in the ones, and then it goes all the way up to in the 60s, I see. So 1, 2, 3, 4, 5, and 6. Okay, so I'm going to do my wins first. And because I don't have them in order, I kind of have to be careful here. I don't have any teens in the wins, but I do have 20s. My smallest 20 looks to be a 20 and a 23. So I'm going to go out with them this way, smallest to largest. So 0 for this 20 and a 23. And then we have a 25. And then a 27. And then 2 29s. And then in the 30s in the wins, I have a, oh, That should have been here. 0, 3, 5, 7, 9, and 9. Sorry about that. Hopefully you didn't make that mistake. In the 30s, we have a 30, a 30, and a 32. And we have 37 and 39 and 39. And then in the 40s, we have a 41 and a 44. And then in the 50s, we have a couple of 50s. And we have a 53, 2 54s, and a 59. And our 60s in the wins column, we just have a 64. So that should be 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, and now likewise, we're going to do the same on the losses. So the losses is where we had some in the teens, this 118. And then in the 20s, our lowest 20 was a 23. And then we had a couple of 28s and 29. And then in the 30s, it appears we have a 32 or 32. And a 38. And then in the 40s, we have a couple of 41s. And 2 43s. 45. 46. And then in the 50s, we have a 50. And a 52. Another 52. 2 53s. And a 55. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And there they are. The next type of graphs that we can make are line graphs. And line graphs are great for numerical data, quantitative data that goes from smallest to largest. And this is going to be using a frequency to make that. So it says in a survey, oh wait, I want to also show you in particular the line graph shown in the example below. The x-axis consists of data values and the y-axis is the frequency points. And the frequency points are connected because they go from smallest to largest. So in the survey, 40 mothers were asked how many times per week a teenager must be reminded to do his or her chores. The results are shown in the table below. So I'm going to show you the Excel spreadsheet, and I will attach that spreadsheet for you to be able to see while you're watching the video, so you can play around with that. Also, if you want to be able to split your screen to be able to see me in the Zoom and your Excel spreadsheet or Desmos at the same time, notice at the top right of my screen, I'm hovering over my closing option and my opening. If I hover over that opening, notice I've got some options here. I could split my screen with 4 different screens, two where one is the majority of the other. So you could do half and half and say, I want to make my Excel spreadsheet half, and then you can make your other half my Zoom screen if you would like. But for now, I'm showing you I'm going to make mine full. So the first example here is the number of times a teenager is reminded and the frequency. We're going to grab all of that data, including the titles, and then grab it with your left. If you press down with your left mouse in the top left cell and then scroll to the right and then bring it down, you can highlight all of those cells. Then click on Insert And we're going to go over here to where there's some options on graphing. And sometimes you want to play around with what you might want to use, but we know specifically we want to make a line graph. So I'm going to go to line graph, and then I am going to hover over the one that I want to make with just one. I just want it to all be one set of data. And I'm going to go to the more line graphs because I really want to do line with frequency. So I chose the more line graphs, and then it brought up the one I want to do. I want to do just this frequency. Now you could change it and make titles if you want. If you want to make titles for your horizontal and your vertical axes, you can go over to this plus sign and then click on axes titles. And then you can click on the axis and write number of times teenager was reminded. And it's going to put it up here in this row right up here, but when you hit return, it actually puts it down in the bar here. Okay, let's go to example 2. So in a survey, I'm going to go back and show you my screen. So let's look at the next one. It says, in a survey, 40 people were asked how many times per year they had their car in the shop for repairs. The results are shown in the table below. Construct a line graph. So we're going to label in Excel the number of times in the shop, and those possibilities were 0, 1, 2, and 3, because nobody answered more than 3 times. And here are the frequencies. It looks like that 2 stops in the shop were the most frequent with 14. Let's go to our Excel spreadsheet and check this out. So here I have a table. Again, I'm going to grab all of my data, and I'm going to go to insert. And again, I'm going to do the drop down for line graph. And I'm going to go down to the bottom and say more line graphs and click on frequency and hit OK. And this is what our line graph for frequency should look like. Should be like increasing up to 2, and then it decreases slightly down to 3 times in the shop with a frequency of 9. You can also go here and say, I want to add titles, like we said before. You can even say, I want to add data labels. And so that's kind of cool. Then you can see the 7, 10, 14, and 19 in the graph. Okay, let's go to the next example. Bar graphs. So in bar graphs consist of bars that are separated from each other. The bars can be rectangles, or they can be rectangular boxes used in 3-dimensional plots, and they can be vertical or horizontal. I should note in here that bar graphs are for a qualitative data because they're not connected. So let's make a note for that. Qualitative data. And that's because the order doesn't matter. Meaning, I could do the eye color, and I could do brown, green, blue, or hazel, or I could do hazel, brown, blue, and green. So the order does not matter with qualitative data. Something we should recognize. So let's look at the example we have here. It says by the end of 2011, Facebook had over 146 million users in the US. The table below shows 3 age groups, the number of users in each age group, and the proportion of users in each age group. Construct a bar graph. So here were the age groups, the number of users. It definitely looks like the age group of 13 to 25 is the largest group, with 45% of that group, of the entire group here, being in that age group. And so you can see that the bar graph that I made here was not using just a number of Facebook users, but it was using the proportion column. You can see that in the title. And I'm going to show you how I made that in Excel. So here's my data in Excel. I grabbed my data, and then I went to insert and bar graph. And you can look at the options. That first one looks like that would be a good one. And there we go. We can click on axis titles as well. You can put in what you would like there. You can put in the data again if you wanted, but I probably wouldn't. They put the data down at the bottom, so that's up to you if you want to do that. Data labels, they're going to do them at the top of the bars. That's an option as well. So let's look at our next example here. And this example says the population in Park City, Utah is made up of children, working adults, and retirees. Again, qualitative data. The table below shows the 3 age groups, the number of people in the town from each age group, and the proportion of people in each age group. Construct a bar graph showing the proportions. So again, we're going to use this column. So I made a column of age groups in Excel and a column for proportion, my percentages. I did not even put the percent symbols. You can just put the numbers, the values. And you can see I did that here. I'm going to grab my data and do insert, and I'm going to click onto my bar graph, and I'm going to show that one. And like I said, you can make a table, you can add labels if you want to, your data labels, all that good stuff. And that concludes lesson 2.1. Catch me back for lesson 2.2.